Hello there, everyone. So today is your quiz, and this is like a little review for your quiz number 6, part 2, because this is our chapter 6, but it's our second part from that chapter, the second part, and we are talking about polynomials. So guys, first of all, I want to show you your quiz. In the first part, it says write the polynomial expression in the standard form and classify to its degree and the number of terms. So you're going to look to all of the exercises, those polynomial expressions. You're going to check if it's in the standard form. If it's not in standard form, please put it in standard form so you won't get confused. Look for the biggest degree, all right, or the degree, or right, the degree of the polynomial, and how many terms does it have? And you know that that combination is going to give you a name, and we're going to be discussing on this review some of those names. That is the little table right there. In the second part, it says add or subtract the following polynomials and simplify. You must show the procedure, meaning that if I do not see a procedure in this part, I cannot give you credit for your work. Even if it's a simple procedure, you have to show me your procedure. I have to see what are you thinking or how are you doing your exercises. You're going to choose the best answer. In the third part, you're going to find the product. What is the product? The multiplication, right? The result of a multiplication of the following polynomials, and you must simplify. Again, you must show the procedure for me to give you credit for that work. Maybe it doesn't fit, maybe you needed an extra page. That is okay. Here you have some instructions, right? It says that the due date is going to be for Monday. It says that the following Google form, in the following Google form, select the correct answers because this is going to be with this Google form, and upload a picture of your procedure of all your math processes. The format acceptable is PDF or image. Failure to show your work will automatically be grounds for the failure of the exercises and therefore for the test. If you fail the exercise and there are too many exercises that I am not seeing procedure for, I cannot give you credit for them, and therefore you will have less point and therefore you may fail the test or the quiz. So again, please show your procedure. This is hyped, meaning that you can just click on it and it will get you to your quiz. In the last part, you have your bonus. And your bonus is a little bit long, but it's pretty easy because it's everything that we have done before. It says evaluate the polynomial and identify. You're going to solve and simplify, and for that you must show your procedure. You must subtract or you must multiply. Once you have solved and simplify, you're going to write the standard form. You're going to answer all the questions. The first one, and again, from 1 to 5 is going to be for subtract. From 6 to 10 is going to be for multiply. And the first one does the same thing on both of them. Show the procedures and write the answer in standard form. What is the answer of that subtraction being solved and simplify, but in standard form? Then it says, what is the degree of the polynomial expression? From that expression that you simplified and that you wrote in standard form, what is the degree of that expression? Then it says, how many terms does the polynomial expression has? Um, Again, how many terms does it have? Then it says, what is the leading coefficient? What is the leading coefficient of that polynomial in standard form? And at last, of course, classify the polynomial expression. Again, that special name that we have for them, depending on the table. And that table is here or in your book, right? So let's do some exercises. Let's try to practice a little bit, right? Just a little bit of what is it that you're going to be seeing on this quiz. So this is like a review. And we have been reviewing this for a very, very long time. Sorry for that. Sorry. Somebody's using my um somebody's using my Xbox, and that is one of the achievements. So sorry for that, guys. So the first part says write the polynomial expression in standard form and classify to its degree and number of terms. So for example, what if you have the following: 20x minus 4x cubed plus 2 minus x2 squared. So let's imagine that we have this as an example, or let's say that this is our example. So the first thing that we need to do is put this in standard form. And again, standard form, it is just to write it from the biggest degree to the smallest degree. And we say the degrees, and we determine those degrees by the exponent of those terms. So I can see that the biggest one will be to the third power, right? The biggest one will be to the third power. Therefore, I'm going to write that one first. So my first one is going to be negative, negative 4x to the third. Which one goes next? Oh, to the second. Minus x to the second. Which one goes next? To the 20. 20 to 20x. That is to the 1 power. Which one goes next? Ah, the constant. Now this is what we call the standard form. So this will be my standard form. Now let's see, they're asking me for the degrees. The degrees of the polynomial is the degree of the highest term or that first term when it's in standard form. And that will be 3. That will be this term right here, and the degree is 3. So the degree of that polynomial expression is 3. How many terms do you have? Let's count them. You have 1 term. Remember that the terms are always divided or separated by addition or subtraction. If they're being multiplied, everything is 1 term. So we have 1 term, 2 terms, 3 terms, 4 terms. We have 4 terms. Which one is going to be my leading coefficient? And again, the coefficient is the number that is being multiplied by the variable. And if it's my leading coefficient, is that first coefficient in the standard form. So in this case, I have negative 4. Now, how can I name this polynomial? Well, I have a degree of 3. I try to highlight it. My degree is 3. So I'm going to have a cubic. It's going to be a cubic something. How many terms do I have? I have 4 terms. 4 or more terms, we call it a polynomial. Therefore, the special name for that polynomial expression is a, let me try to erase this. There we go. There we go. It's a cubic polynomial. And again, the name will always depend on how many degrees does it have and how many terms does it have. We always write the degree first and then the term. If it has 0 degree, then it will be a constant. It will be just a number. If it has 1 degree, just like something x, right, just a variable, then we call it linear. If it has 2 degrees, for example, something like this, if this was my um, leading coefficient, if this would be the first one in my standard form, then it would have been a quadratic because it was 3, right? The degree, then it was cubic. If the degree would have been 4, it would have been quartic. If the degree would have been 5, it would have been quintic. If the degree would be 6 or more, we call it depending on the number, right? 6th degree, 7th degree, 8th degree, 9th degree, 10th degree, etc., etc., right? If it only has 1 term, meaning that it doesn't have an addition nor subtraction dividing anything, then it will be a monomial. If you have 2 terms, again, they are divided by adding or subtracting, then you will have a binomial. If you have 3 terms, will be called a trinomial. If you have 4 or more, then it's going to be a polynomial. Let's practice some adding and some subtracting, okay? So for example, let's say that we have an exercise that looks a little bit like this. 2x squared minus x plus x squared plus 3x minus 1. Let's say you have that example. We are adding, right? We are adding. And when we add, the first thing that or subtract, the first thing that we need to think is, can I solve anything inside the parentheses? If my answer is no, then I can dissolve those parentheses. For example, this is going to be 2x2 minus x plus x squared, right? Plus 3x minus 1. Then I can rearrange for it to have all the like terms together. And again, a like term is that combination of variables and exponents that are the same. This one and this one are like terms. And this one and this one are like terms. Why are they like terms? Again, they share a combination, right, of exponents, right, of variables and exponents. For example, x to the second, or just the x. They have that same combination of variables and exponents. So let's rewrite it. 2x to the second plus x. I used to call it square, right? We also call it square. Minus x plus 3x. Now I don't have any other constant, so I'm just going to leave the negative 1. Now I can combine my like terms, right? 2 plus 1, and remember that there is always an invisible one when we are not seeing anything. There's always an invisible one right there. So 2 plus 1 is 3, x to the second. 1 plus 3 is 4. I'm sorry, this is negative x. Sorry, it's negative x. So is negative 1 plus 3 is positive 2x. And the minus 1 all by itself. And that is in standard form from the biggest to the smallest. And that will be my answer, simplified. Let's try another one. What if you have something like this, a little bit more complicated, okay? 4b to the 5th plus 8b plus 3b to the 5th plus 6b minus 7b to the 5th plus b. Now, there's a little something different here, right? I can actually simplify what I have inside my parentheses. I have like terms inside the parentheses, so I can simplify before I combine it with the other one. So I have b to the fifths and b to the fifth. I also have my b's. So I can combine my b to the fifth, and I can combine just the b's. But for that, I'm going to first leave the first group all intact until I solve the other group. And 3b to the 5th minus 7b to the 5th, 3 minus 7, right, is negative 4b to the 5th. And 6b plus b, again, remember that there is always a 1 there. So that would be 6 plus 1. That would be 7 plus 7b. Now I can dissolve the parentheses. 4b to the 5th plus 8b minus 4b fifth plus 7b. And again, I'm going to combine my like terms. I could even rearrange them if I wanted it to. 4b to the 5th minus 4b to the 5th plus 8b plus 7b. And you know something. How much is 4? I can combine those two, right? 4 minus 4 is 0. And 0 times b to the 5th is 0. Therefore, all of that is just going to be a big 0. I can even cancel them if I wanted to. 0 plus 0 plus. Let's see how much is the other combination. Have 8b plus 7b, and a plus 7 is 15b. And 0 plus 15b, I can just put the 15b. And that would be my answer. The degree of that would be 1. It only has one term. So if I were to call it, it would be a linear monomial. Let's do another example, but this time let's abstract. So let's think, for example, that you have the following expression. A to the fourth minus A2, or 2A, sorry, minus 2A minus all that group, right? Minus 3A to the fourth minus 3A plus 1. And we have already told you, or we have already known the rule for I always forget the name. Sorry for that. It's kind of late. For integers, for the rules for integers, it always says that if I'm going to change from subtraction to addition, the first term is going to stay the same. In this case, would be the first group. It's going to stay the same. I can change that subtraction to an addition, but then I have to change all the signs of the second term, right? Or in this case, the second group. So just like we do with integers, we can do with polynomials. The first group stays the same. I can change the change. I'm going to do this in color. I can change that subtraction to an addition. But if I do that, I have to change the signs of all my group, right? Of all the group. Now the 3a to the fourth is going to be negative 3a to the fourth. Now the minus 3a is going to be plus 3a. And the plus 1 now is going to be negative or minus 1. Now I can look for like terms. For example, those are my like terms. And I have another like term right there. And now I can combine them. A to the fourth power minus 3a to the fourth. Remember that there's always an invisible one right there. So that would be 1 minus 3. And 1 minus 3 is minus 2, so or negative 2. A to the fourth power. Negative, right? I'm here right now. Negative 2a plus 3a, right? Negative 2 plus 3 is 1. It's going to be plus, but we don't write the 1, right? So we just leave the a minus 1. And again, that will be my solution simplified. It is in standard form. The degree of that polynomial is 4. The leading coefficient will be negative 2. What else can I say? It has 3 terms, right? And if it has a 4 degrees, we call this, we can check the table right here, a quartic. Call it a quartic. And it has 3 terms. So it's a quartic trinomial. Quartic trinomial. Let's do and now let's do an example with multiplication. In the third part says find the product of the following polynomials and simplify. You must show the procedure. Again, if I don't see the procedure, I cannot give you points for your work. And the product is just a multiplication, right? That's a result of a multiplication. Sorry, it is kind of late, so. So for example, let's say that you have 5x squared times 4x cubed. And I don't know if you remember, But every time we multiply variables with exponents, we can just add those exponents, right? And that will be my multiplication of exponents. So I can do the same thing when I'm doing polynomials, in this case monomials, because they're just one term. First things first, I can multiply my coefficients, and 5 times 4 is 20. Then I can multiply my x with my x, right? Let me do this in space, more in more steps. This is the same as 5 times 4 times x to the second times x to the third. 5 times 4 is 20. X to the second power times x to the third power is the same as x2. The second x to the second x2, 2 plus 3 is going to be the same as 20 x to the fifth power. And that will be my answer. Let's do one more. Let's complicate that one a little bit more. What if you have the following expression? 5xy times 2x to the second y. Now I have two variables, but again, all I have to do is multiply my coefficients with my coefficients, my x's with my x's, and my y's with my y's. So again, 5 times 2 is 10. Sorry for that. Again, somebody's using the Xbox and they're using my username. Then I can multiply my x's with my x's, and x times x to the second power is the same as x, 1 plus 2. And then my y's with my y's. And remember that there's always like a 1 there that we never write. It's going to be y, 1 plus 1. And now I can simplify my expression. It will be 10 x1 plus 2 is 3, y1 plus 1 is 2. And that would be my answer. And again, I like to always put them in alphabetical order. X goes before the y. Let's do another example. Let's try to complicate this one a little bit more. What instead of two monomials, you have a monomial times a binomial? For example, 4a times a to the second b plus 2b to the second. What if I have that? Now we have to use the distributive property, where I would take the first term and multiply it with the first term of the group. And we have 4a multiplied by a to the second times b. And then I will do the same thing with the second term, plus 4a, that is a 4, times 2b to the second. Again, I'm doing the long road. I know we have practiced this a little bit quicker, but I'm just taking my time solving it and showing you all the procedures that you may use. Now, we don't have a coefficient, right? Here, I don't have a coefficient, so it's like if I had a 1. 4 times 1 is 4. Then I can take my a's times my a's. a well, to its first power because it's only have one, even though it's visible right there, plus 2. And I don't have a b, so I'm just going to leave a b there. Now I'm going to do the same thing with the other two groups. 4, it's going to be 4 times 2. 4 times 2 is 8, plus 8. I don't have an a, so I'm just going to write the a. And I don't have a b to multiply by, so I'm just going to write the b. And now I can simplify my expression. 4a to the third, b plus 8ab second. And that will be my answer. Now let's complicate this a little bit more, just a little bit. And the same way that I'm doing this, you can do a binomial times trinomial and other ones. What if you have a perfect... Now let's talk about the ways that we can solve a perfect square binomial, right? For example, if you have x plus 2 squared, you know that that is the same. If I had x to the second power, it would be the same as x times x. So the same thing happens with the group. This would be x plus 2 times x plus 2. And I'm going to do this in a few ways. This is the standard form that I normally use. Again, I'm going to take my first term and multiply it by the group. Then I'm going to take my second term and multiply it by the group. Plus 2x plus 2. Now I can use the distributive property again. X times x is x to the second. X times 2 is 2x. Same thing, 2 times x is 2x. And 2 times 2 is 4. Now I can combine my like terms. X to the second. 2 plus 2 is 4x plus 4. So that is one way to do it. The other way that we can do it is with the FOIL form, right? The FOIL form. And the FOIL, I like to use colors so you can see what am I multiplying. The FOIL method. And the FOIL method says that I can multiply my first terms, right? My first terms together. And x times x is x to the second. Then it says that I can multiply my outer terms. X times 2 will be 2x. Then it says that I can multiply my inner. The ones are in the inside of those of that term, right? 2 times x again is 2x. And for the last one, it says I can multiply my last two terms. And 2 times 2 is 4. Again, I have terms that are alike, so I can combine them. So I can combine them. 2 plus 2 is 4x plus 4. As you can see, we get to the same place. And the other one, of course, is using the formulas for special polynomials, right? And those formulas are, I'm going to write them around here somewhere. If you use the formulas, for special polynomials, right? So if I have something that looks like a plus b to the second, I can rewrite them as a to the second power plus 2ab plus b to the second. If um, if I have a minus, right? Now it's a minus b, right? Then all it changes is just the sign of the second term. A to the second minus 2ab plus b to the second. The other one that it says is if I have special opposites. For example, if I have a plus b times a minus b, then I can rewrite this as a to the second minus, and I'm going to do this in blue so you can see and remember the minus or the subtraction, minus b to the second. Those will be my formulas for special polynomials. So in this case, I could use this one. I just have to determine which one is going to be my A, which one's going to be my B. I can say that this is going to be my A, and that this is going to be my B. So I can rewrite this, right? It's going to be A to the second, right? A to the second. So if x is A to the second, plus 2 times A times B, this case is 2, plus B, in this case is 2, to the second power. Now I can solve x to the second power is x to the second. I cannot do anything more there. But I can multiply my my numbers, right? 2 times 2 is 4. And I'm just going to put the x right there. Plus, and 2 to the second power is the same as 2 times 2. And that is going to be 4. And that would be my expression simplified and in standard form. Let's do one more. What if instead of adding, we were subtracting that perfect square? Minus b. I'm sorry. If you have y minus 5 to the second, well, you can use this form. Y will be my a, 5 will be my b. Y to the second minus 2a b plus b to the second power. Y to the second is going to be y to the second. Negative 2 times 5 is negative 10. Y. And 5 to the second power is the same as 5 times 5, and that is 25. And that would be my answer. Let's do one more. If I can, I'm going to try to do 2 more. What if I have a to the second power plus b to the third times a to the second minus b to the third. Well, you know something that looks a lot like this. The only difference is that they're not elevated, but they have the same pattern, right? They're both multiplying the same combinations of variables and exponents, except that one is being added, the other one is being subtracted. So I can say that my a is going to be a to the second minus b to the third to the second power. Oof. You know, if you have something like that, instead of adding like we do when we multiply exponents 2 and 3, it's the same as 2 plus 3, that would be x to the fifth. If we're multiplying them, right, if we're pre-elevating it, x to the 2 to the second power is the same as x to the second times x to the second, and that would be x to the fourth. You're multiplying it now. So this would be a to the fourth power minus b. 3 times 2 is 6. And that will be my answer. Pretty simple, right? Let's do one more. Now, what if, and I am making this up, right? But what if I have 4a plus 2b times a, gonna erase all of this because I need the space, times a to the second b plus 2ab plus 2b to the second. What if I have a binomial times a trinomial? Well, there are a lot of ways I can do this. Again, I can take the first term and then multiply it by the second group. Then I can take the second term and multiply it by the second group. And that's how I'm going to solve it. But if you want, you can also just take the first term and then multiply it by the first term of the other group. Take the first term and multiply it by the second term of that group. Take the first term and multiply it by the third term of that group. Then take the second term from the first group times the first term of the other group, and so on until you multiply them all together. But let's do the traditional way. So I'm going to have 4a, I'll do this in another color. This is going to be blue. 4a times the group, right? 4a times the group. A to the second, b plus 2ab plus 2b to the second. We'll do another color. 4 by second term times the group plus 2b. A to the second, b plus 2ab plus 2b to the second. Now I can use the distribute property again. I was meant to do that one in the red. 4a times a to the second power times b. I don't have nothing to multiply it for, right? That would be 4 times 1 is 4. Then my a's with my a's, a times a to the second power is a to the third. And my b's with my b's, and I only have one b. Then I do the same thing with the second term. 4 times 2, right? 4 times 2 is 8 plus 8. A times A is A to the second power. And I don't have a B to multiply with, so I'm just going to put the B. Now I do the same thing with the last term right there. 4 times 2 is 8. I don't have an A to multiply by, and I don't have a B to multiply by either. So I'm just going to put them there. Let's check out our second group. 2b times a2 to the second power times b. Again, I don't have another coefficients to multiply, so that will be the same as 2 times 1, and that is going to be 2. B, well, I don't have an a here, so I'm just going to pass the a. Why? Because I like it in order. B times b is b to the second power. And I do the exact same thing with the next term. 2 times 2 is 4. B, well, I don't have an a, so I'm just going to write the a. And b times b is b to the second power. This is getting a little bit long. Don't worry. We're almost there. Now the last one, the last term. 2 times 2 is 4. B times b to the second power is b to the third. Oof, that was a lot. Now this is going to be a little bit difficult, but let's see if we have anything that we can put together. I don't know if we do. Well, yeah, I do have, right, the same combination of a's and b's and exponents. So a to the first power, or a times b to the second power. Those two are like terms. Do I have anything else? I'm just looking for it. I don't think so. I don't think I have anything else. So I can rewrite everything and just combine those two. I'm going to combine those two. Let's see. We're going to have A, B. Now let's combine those two. 8 plus 4, that will be 12 plus 12, AB to the second. I'll do everything else in the other color. Oops, that's an ugly 4. There we go. And that would be my answer. The only thing I could was just combine two terms together. And that will be my answer. Guys, I do wish you the best of luck. Oh no, let's do this. Let's do the bonus. Let's do the bonus. Forgot the bonus. And the bonus is gonna be just the same thing as we have done normally in class. I'm gonna give you something to add or subtract or multiply. We go to the test. You're gonna see it. That is not the test, sorry. If you go to the test, you're gonna see it. That you're gonna subtract, you're gonna multiply. So again, let's say that you are multiplying for sakes, just for sakes of an example. Say you're multiplying, it says multiply That is, let's just multiply. 5x to the second, we already did this one, times 4x to the third. Let's add a little something to make it a little bit more different. Plus 3. X plus 1. Let's make it a little bit more. So again, I can use the distributive property. 5, the first term with the first term from the first group to the second one, and with the third one. This is the distributive property. So 5 times 4 is 20. X to the second power times x to the third. So third power, right? Be 2 plus 3. 5 times 3. I'll do this again in blue. Let's see. 5 times 3 is 15 plus 15. X to the second power times x is x to the third. Or I can write it, 2 plus 1. And x to the second power times 1. This in another color. Gonna be 5x to the second. Now I can solve this. It's gonna be 20 x to the fifth plus 15 x to the third, or we can also call it cubed, plus 5 squared. It is in standard form, right? Then I'm going to tell you if is it in standard form? Yes, it is. What is the degree? The degree is 5. How many terms? Well, it has 1, 2, 3 terms. What is the leading coefficient? 20. What is the name, or classify the polynomial? What is the name of that polynomial? Well, if it is 5, we can go back to the table, right? We can go back to the table, right? It is 5 is quintic, right? Then it would have been quintic. I'm going back there. Be quintic. And because it has 3 terms, it will be a trinomial. Oh, I forgot to move this one. Wait, a bit too much. There we go. Be a quintic trinomial. This is an R, sorry. Trinomial. And that is what you have to do for the bonus. And that will be all. That will be all. Then you're gonna go to your quiz, choose the correct answers. At the end of the quiz, says upload your work. There is a video that I have done already how to upload that work. You can, if you answered this on your cell phone, it's even easier, because then you could take photos with your cell phone and just upload it right away in this form. If not, you can transfer them to PDFs and then upload them here in your computer. Guys, I won't take any more time. I know I've been talking a lot, and I'll let you be. I wish you the best of luck in this quiz. And remember, if you have any questions or doubts, you can contact me by WhatsApp. Bye, guys.